You think you feel gravity pulling you down, right? Step on a scale, see the number, and assume Earth is tugging at you. Drop a pen, watch it fall, and feel certain you understand the force that binds you to the ground. Simple, obvious, unquestionable, yet that simple understanding is completely, fundamentally wrong. You never actually feel gravity pulling. Not once. What you feel is something entirely different. The floor pressing up against your feet, holding you back from following your natural path through space. Every step, every object resting on a surface, every falling apple is a silent demonstration of a misconception we've carried for centuries. Imagine the moon orbiting Earth. It's falling constantly, yet never lands. A ball rolling along a table moves straight until it meets friction. But the motion itself isn't mysterious, it's natural. In these everyday experiences, we accept a force pulling things down, but reality tells another story. You don't feel any pull. Only a push prevents you from floating into the void. The so-called force of gravity is invisible, not because it's magical, but because it doesn't exist in the way you think. This cognitive dissonance is the first step toward understanding the universe more profoundly than most people ever will. Even our greatest thinkers initially struggled with this. Centuries ago, the idea that Earth could exert an invisible tug across space seemed perfectly reasonable until careful observation exposed inconsistencies. Why does the moon keep circling instead of crashing? Why does the apple fall at a predictable rate? Why does the floor resist your weight in the exact amount necessary to prevent acceleration? Newton's genius provided answers, but even his law left questions unresolved. How does gravity act across empty space? What carries the message instantly between distant bodies? Here's the essential paradox. Everything you perceive as weight, as downward force, is a reaction to your environment resisting motion, not an invisible pull. The floor, the chair, the branch of a tree all are pushing, keeping you from following the natural paths that objects would trace in empty space. Standing still feels normal, but in reality, you are being subtly accelerated every moment, held back from freedom by surfaces that refuse to let you move as nature intended. If what you feel isn't a pull, then what is really happening? To understand, we need to revisit centuries of careful observation, experimentation, and insight. The next step is a journey through history, from meticulous measurements of planetary motion to groundbreaking discoveries about how objects truly move. Only then can we begin to see gravity not as a mysterious force, but as a geometric truth woven into the fabric of reality. Investigation centuries before Einstein reshaped our understanding. Humans struggled to make sense of the patterns in the sky. Observing the motion of planets seemed simple at first, yet the universe was anything but obvious. Tycho Brahe spent decades meticulously recording the positions of Mars, Venus, and the other wandering stars night after night, using brass instruments to measure angles with incredible precision. Most would have shrugged at minor deviations, assuming error or luck, but Brahe trusted the data. Every fraction of a degree mattered, and these small differences hinted at truths that would eventually overturn centuries of assumptions. Johannes Kepler inherited Brahe's data, determined to uncover the hidden order. For years, he tried to force the planets into perfect circles, as tradition demanded. Predictions came close, but Mars always missed by 8 arc minutes. Most people would have chalked it up to imperfection, yet Kepler refused. 8 minutes of deviation revealed the universe's secret. Planets did not move in circles. They traced ellipses, with the Sunday at one focus. A subtle, elegant pattern that seemed invisible at first, but was revealed through precise measurement and relentless curiosity. Meanwhile, Galileo Galilei approached the problem differently. He ruled balls down ramps, timed their acceleration, and measured their motion meticulously. To most, this would have seemed trivial, but Galileo was uncovering a radical truth. Motion does not require a constant push. Objects naturally maintain their state of motion, unless acted upon by an external force. A ball rolling on a flat surface keeps moving, not because something drives it forward, but because inertia is the natural condition of matter. Friction and resistance, not motion itself, demand explanation. Isaac Newton then synthesized these insights. He saw that the same principle governing a falling apple also governed the orbiting moon. Planets tend to move straight yet curve endlessly around the sunday. The force he called gravity explained this motion, but even Newton admitted he did not know the underlying mechanism. How could action occur across empty space instantly? What invisible agent connected distant bodies? His mathematics worked perfectly, but the mystery remained. The universe obeyed a law whose essence no one could see. The brilliance of history lies not only in discovery, but in the questions left unanswered. Observing, measuring, and refusing to accept simple explanations paved the way for a deeper understanding. Newton provided the first predictive framework, yet his theory was only the beginning. To truly grasp gravity, we must now journey from these historical milestones toward a revolutionary insight, one that would reveal gravity as something entirely different than we ever imagined. You think gravity pulls, but what if that assumption is completely backward? Newton's laws gave us incredible predictive power. Apples fall, moons orbit, planets trace ellipses, but they never explained the deeper truth. How does one object reach across empty space to influence another instantly? Newton himself called it action at a distance and admitted he didn't know. The mathematics worked perfectly, yet the universe kept its secrets. Enter Albert Einstein. His insight began with a simple question. What if the apparent coincidence in Newton's laws, where inertial mass equals gravitational mass, is actually telling us something fundamental? What if gravity isn't a force at all? Imagine being in a sealed room with no windows. You feel your usual weight pressing down. Are you on Earth, or are you inside a rocket accelerating upward at 9.8 meters per s econ squared in the void of space? Drop a ball. Throw it sideways. Every experiment behaves exactly the same. There is no way to tell the difference. This is the equivalence principle. The sensation of gravity and the effects of acceleration are indistinguishable. Einstein realized that what we perceive as a downward pull is actually geometry in action. Objects in free fall, the apple dropping from a tree, astronauts floating in orbit, the moon circling Earth, are not accelerating at all. They are following the straightest possible paths through curved space-time. Massive objects like planets and stars warp the fabric of space and time itself. Gravity emerges not as a mysterious force, but as a natural consequence of geometry. You standing on the floor are being deflected from your natural path by the upward push of the ground. The weight you feel is not gravity tugging down. It is the floor resisting your motion through the curved geometry of space-time. Consider light. According to Newton, it should travel in a straight line, unaffected by gravity. But in Einstein's universe, the path of light bends near massive objects because the space through which it moves is curved. During a solar eclipse, starlight passing near the sunday appears displaced. The universe itself becomes a visual demonstration of curved geometry. Every orbit, every falling object, every rising tide reflects the invisible structure of space and time. The apple, the moon, and the distant stars all obey the same rules, yet none are being pulled in the way we once imagined. This shift from force to geometry is profound. It challenges our intuition, overturns centuries of assumptions, and transforms how we perceive the universe. What seems simple, a ball falling, a planet orbiting, is actually a complex dance along curved paths shaped by the mass around it. Newton's equations remain practical tools, but Einstein's insight reveals the true mechanism, elegant and invisible. Gravity is not a push nor a pull. It is the shape of space itself. Understanding this requires letting go of old mental models. Once you accept that objects move along the straightest paths through curved space, everything begins to make sense. From the apple in your hand to the orbit of the moon, From free-falling satellites to bending light, the universe follows a logic far deeper than force. And with this perspective, phenomena once mysterious now appear natural, inevitable, and astonishingly applications. If gravity is not a force, then everything we thought we knew about falling objects and cosmic motion suddenly transforms. The same principle that explains a dropped apple also governs some of the universe's most extreme phenomena. Take black holes, for example. These are not simply places of intense gravity. They are regions where space-time curves so sharply that the straightest possible path leads inward, trapping everything, even light. The apple falls toward Earth, but near a black hole, light itself follows a spiral path inward, disappearing from view. One principle, repeated across scales, explains both the mundane and the extraordinary. Even closer to home, the moon's orbit demonstrates geometry in action. It falls toward Earth continuously, yet never lands. Its sideways motion and the curvature of space create the elliptical paths that Newton calculated mathematically. Ocean tides are another manifestation. The moon doesn't pull water directly. Its mass warps the space around Earth, creating subtle shifts that move oceans predictably. Planets, comets, and satellites all obey the same underlying rule. They follow the curves carved by the mass around them, not invisible forces tugging across empty space. Consider the Earth itself. Its round shape is not molded by a mysterious inward pull. It emerges naturally from space-time curvature. Every particle, every drop of water follows the straightest path through curved space. When matter obeys these invisible geometric rules uniformly from all directions, a sphere forms. Earth's shape is the product of natural geometry, not force. Astronauts orbiting hundreds of miles above the surface are not weightless. Because gravity has vanished, they are falling freely, moving along curved paths that match the curvature of space beneath them. The result is a sensation of floating, an everyday experience that defies ordinary intuition but is perfectly consistent with Einstein's vision. Even light, massless and seemingly untouchable, obeys the same rule. Gravitational lensing occurs when light bends around massive objects, creating distorted images of distant galaxies. This isn't magic. It is space-time telling light how to move. One principle, curvature, explains the dance of apples, moons, stars, black holes, and photons alike. From predicting eclipses to launching satellites, understanding gravity as geometry allows us to see the universe, not as a collection of mysterious forces, but as a coherent, elegant, and interconnected system. Recognizing gravity as geometry transforms ordinary observations into extraordinary revelations. Every falling object, orbiting body, and beam of light becomes a clue, a window into the invisible architecture of the cosmos. And the more we pay attention, the more we see how simple and astonishingly beautiful the universe really is. Now that we understand gravity not as a force, but as the curvature of space-time, the universe appears in a new light. The weight you feel standing on the floor is not Earth pulling you down. It is the floor pushing against you, deflecting you from your natural path through curved space. The apple falling from a tree, the moon orbiting Earth, astronauts floating in orbit, light bending near massive stars, all obey the same underlying principle. Every motion, from the smallest to the grandest, is guided by the geometry of space and time. This realization changes more than physics. It transforms how we perceive reality itself. Objects don't fall because they are pulled. They follow the paths dictated by the invisible contours of space-time. Massive objects create curves. Smaller objects follow them. And the universe unfolds according to these elegant rules. What seems random or mystical is actually beautifully ordered. The laws that govern a falling apple are the same laws that dictate the motions of galaxies billions of light years away. One principle explains the cosmos, both near and far. Understanding gravity as geometry invites us to see the world differently, with curiosity and wonder. It challenges assumptions, reshapes intuition, and rewards those willing to question the obvious. Science becomes not a collection of facts, but a lens through which reality reveals itself. Every observation, every experiment, and every insight brings us closer to the astonishing truth. The universe is a coherent, interconnected fabric, and we are participants in its geometry. So the next time you step on a scale, watch an apple fall, or gaze at the night sky, remember this: gravity is not a pull, it is the invisible shape of space and time itself guiding every motion. You are not being dragged downward, you are following the natural geometry of the cosmos. And that understanding is far more beautiful and far more profound than any simple force could ever be.